Alright, so picking up where we left off, again, my name's Justin. I'm demonstrating creating a Eurorack printed circuit board from scratch, a real simple one, an active multiple. In the first episode, the first video, we went ahead and created our schematic using both the components that come kind of built into EasyEDA as well as components that we downloaded from the library, specifically the jacks. One thing I didn't mention in my previous video that I'd like to mention is that one good practice is to create an extra project in EasyEDA and call it your Eurorack library, for example. And whenever you find a good component with a good footprint, then you want to keep that, you want to copy that and paste that into that, so that the next time you do a project, you don't have to go through the process of searching through the library to find it. There are ways to create your own libraries as well. I'm not going to cover that, but I find that creating that extra project is just a real simple way of doing that. You can also save entire sections of a project, of a schematic in that project. For example, I could just highlight all of this power section. I could copy that and paste that in, and now whenever I need a power section, I can just grab it from there, right? Alright, so last video we created this schematic. We think it looks good. We're going to do a couple quick checks here. I'm going to click over here on Design Manager, right? And I'm going to explain what this window is. It has a list of our components, right? It tells us all the different components that we have. If the list gets out of date, you can hit this button to refresh it, right? The nets, these are all the connections we have in our schematic. So if you look, they all look fine. But let me give you an example where something wouldn't be connected properly. So let's go here, and we'll delete that. What I did was I just deleted the wire that goes to ground there. And I'm going to reset that. Notice that now we have a big X next to ground, right? And we have a warning sign next to J1 ground. That's telling us that we're missing a connection. We're missing a net, right? So this is a quick way of checking your connections to make sure that everything is connected and that that there's no issues. So if I go ahead and I click on the wiring tool and I rewire that one, you'll notice that it doesn't change over here until we do the refresh, right? And the same thing if I uncheck, let me escape out of this, right click to do escape sometimes. I'm going to click on that X and delete it, and I'll run this again, and you'll see that now we've got a warning on that normalization connection, right? Because I haven't told it where I want that to go. If I don't want it to be connected to something, then I will just click on the X and add that, and then if we do a refresh, there we go. Alright, so we've got our schematic imported into or created inside of EasyEDA, and now we want to start creating the printed circuit board. So what we're going to do is we're going to save this first. You'll notice that it has a star next to it saying it hasn't been saved. So I'm going to save it here, and now we've got it saved. Up here is a button. It's got a box with a couple looks like pads on a PCB. It says Convert Schematic to Printed Circuit Board. That's what we want to do. We're going to click on it, and you'll notice it didn't ask me any questions. I want to show you one more thing before we actually go into the printed circuit board design. If I do disconnect one of those items, right, it knows now that there's something wrong because I didn't connect that. So I'm going to save it. You have to save it before you can create a printed circuit board. And then I'm going to try to convert it. It's going to ask me and tell me that there's some unfinished nets. Do you want to check the nets first? You generally speaking, you want to click yes because you want to know what's wrong, right? And you'll notice that over here it's telling me the ground is now disconnected. So once again, I'll go back and wire that up. Okay, and then I will refresh this. Now when I save it and I click on Create Printed Circuit Board, you'll notice it didn't ask me that question because it ran the test and everything passed the test, right? So now we're at the point where we're creating a new PCB. The way this works is that it will look at all your components and it will say, the program that is will look at them and it'll guess how much space you need on your printed circuit board. You can accept that, but typically you're going to want to set your own size. And you can either do it here or you can do it in another place. Let me show you the other place. I'm going to go ahead and hit cancel. And you'll see that it created, this is the printed circuit board outline, and it created that. You may notice something a little bit funky here. These capacitors are huge, right? We don't want them that big. We're using little 100 nanofarad capacitors. So I'm going to have to show you how to fix that. But that's part of the tutorial, because you're gonna have that happen often. Now, the way I like to make these printed circuit boards is I like to make them based on the origin, right? So I'm going to go ahead and move this stuff out of the way. So I'm just going to highlight it all and move it out of the way, right? Now we're going to set the dimensions for our printed circuit board. So if you go up on the top here, you got tools and you've got set board outline. That brings up that same screen that sets the board outline. Now, one thing that's important with printed circuit board design, it can be very frustrating, but it's something to recognize, is that there's 3 different units, right? You've got mils, you've got inches, and you got metric, right? So that can get pretty confusing. In this board, I'm going to use metric, so I'm going to go ahead and hit cancel here. And up here, you'll see where you get to change your units. You got millimeters, or mils, inches, and millimeters, right? So in this case, I want to use millimeters, so I'm going to switch to millimeters. You can switch back and forth as many times, and you will often switch when you are creating a printed circuit board. Alright, so now I'm going to go back to tools, and I will set the board outline. Alright, we want a rectangular one. We're not using a circle or a round rectangular, and it's got our dimensions here already. Now the start X, I want it to be at 0, right? Because I want it to start at the 0 origin. We're going to make our printed circuit board, just for practice, we're going to make it 30 millimeters wide to start with. We'll see how that fits. You can always change this as we go. Now the start Y is interesting. We want to make our printed circuit board 100 millimeters tall. So I'm going to put the 100 millimeters here, and then I'm also going to put 100 millimeters here, and I will hit apply. Now if you look at our printed circuit board, it's based on the origin. That's important, and it's in this quadrant of our X. If I go back to the set board outline, if I put start Y at 0, it'll move it down here below. That's not really a problem. If you prefer that, that's fine. I prefer to have it above the origin, so I will go back to tools, set board outline, and I will set the Y at 100 millimeters. Now, generally speaking, when making your Eurorack modules, of course, the Eurorack design is the panel is going to be 128.5 millimeters tall. So 100 is a good spot. You can go up to 110, but you wouldn't want to go too much taller than that, right? So now we're going to start seeing how our components fit on this this module, right? So we've got our jack 1. Remember, that's going to be our input jack. So I'm going to go ahead and move it here, and I'm just going to start dragging stuff to see how it fits. Okay, so we've got all our stuff here. You'll notice that's not really lined up, right? We kind of messed up as far as the spacing's not right and all that. Let me show you how you can handle that. I'm going to change back to inches here, right? Because I want my snap to be in inches. Like I said, it's frustrating with PCB design because we have to switch back and forth between inches and millimeters, and a lot of this is just your preference. So you'll be able to decide on your own what you want, right? So I'm going to right click on the desktop, on the background, right? And I'm going to click on Canvas Attributes, right? This part here shows how big our grid is. It's currently set to 0.1 inches. It also sets the snap size, right? And what I want the snap size to be 0.05, right? So not 0.005, but 0.05. I'm not going to worry about this alternate snap. I'm just going to click on OK, or click on Update. Now when I move these guys around, you'll notice that they snap much tighter, right? So if I look at this, I can move it around. It's snapping based on the 0.05. Now what that lets us do is we can start getting some good spacing, right? If I move all these guys tight together, we can see our spacing here, like that, right? So now we could decide, okay, I want them to be, let's see, 1, 2, 3, 4, 5 clicks apart, right? So let me move this one out of the way, and we'll do get this down to here, and we'll go 1, 2, 3, 4, 5. So this is one way to set your spacing, right? And we'll go here, 1, 2, 3, 4, 5. Okay? Let's see, I don't know if I got that right. 1, 2, 3, 4, 5. Now let's talk about how these are lined up. Now, where the center of this component is controlled by the footprint right? Every component has a schematic and then a symbol, and then it also has a footprint. So depending on where the person put the origin on this footprint is kind of where it's going to snap to. So you have to pay attention to that when you're laying this out. Now let's say I wanted to put this right on the edge of the PCB, right? I want this jack to be all the way to the edge of the PCB. Right now I can't do that because it's going to snap too tight. So I would right click on the back here, I would go on the background, and I would click on canvas attributes, and instead of 0.05 I'm going to do 0.01. And then I'll click update. Now you'll see I can move it much tighter, right? I don't want to move it up and down because I already set that spacing. But I can get it right on the edge of the PCB. Alright, and then last one, jack 1. Alright, there we go. Alright, so now let's go back. I'm going to go back to attributes. I'm going to change, oops. If you get that, you just have to click on the background. I'm going to go to canvas attributes, and I'm going to change that back to 0.05. Alright, let's work with some other components now. We know we're going to want to put our power down here, right, somewhere down there. We've got our chip here. We're going to stick that right there for now. And we've got our resistors. Now, we didn't talk about these lines. These are called rat's nest. And basically they're telling us how we need to connect these items, right? So if we look up here, we have the layers and objects window, dialog box. So these are all the different things that we see. And one of those items is the rat lines. So I can change the visibility of the rat lines and do that. If I want to, I can change the color of the rat lines and things like that. Whichever layer has the pencil on it is the layer you're working on at the moment, right? And we'll talk about that in a moment once we start routing our components. Alright, so let's finish moving these resistors around. We got resistor 1. So we have an option. We can put the resistor close to the jack, or we can put the resistor close to the chip. For now, let's just stick it close to the jack. Gonna line it up right there, nice and straight, right? Got resistor 2. Now remember, this is just a tutorial, so I'm not going to go too crazy as far as placement of components. I'm just trying to show you how you could do it. One option, anyways. Right, so this one, excuse me, let's see, this one goes here. And let's go ahead and rotate this one. Again, you can hit the R to rotate components just like in the schematics. If we look here, it's connected to the middle terminal on J3. So let's just place it. Instead, we're going to place it close to the IC. Alright, so we'll go with that. Next up, we're going to move these capacitors, right? We got our electrolytic capacitors here. And then we have these really big axial, well, I don't know if you call them disc capacitors, film capacitors, whatever. We're going to change that footprint in a moment. Excuse me. So now let's look real quick at our capacitors. Remember, we said that pin 1 is negative 12 volts. That you can see when you zoom in close enough, you'll get labels on each pad. So we've got our minus 12 volts and our minus and our ground, and then our plus 12 volts. So if you look at this right now, our lines are kind of crisscrossed, right? So we're going to rotate this twice, and that gives us that orientation, right? Now, once you're dealing with the footprints, you can also rotate the labels. Right? That gets us the label rotated to the right orientation, and we can place it wherever we want. Now, we're going to do the same thing with this one. If you notice, we'll get it lined up there, and you see that the cursor, the red cursor, when we move this, is lined up on the center of the capacitor. So that lets me help get it lined up with the other capacitor, because I want them to be lined up. This one has the crisscross as well, so we'll do a rotate twice, and now we've got the ground and the plus and those guys in line, right? Let's go ahead and change our footprint. We're going to save this printed circuit board, right? We're going to go back to our schematic. Now, if we look at these guys, if I click on one of those on the symbol itself, over on the right side, we've got footprint radial 0.03. Right? So it's a radial capacitor and it has a footprint of 0.03. That's too big. We want to change that. So we're going to click here in the window. right? This gives us a list of all our components along with their footprint. You'll see that the two capacitors, capacitor 3 and capacitor 4, both have that radial 0.3 footprint. So we want to change that, and we're going to go in here, we're going to search on a 0.1. We want it to be smaller, right? We don't want a huge capacitor. So we're going to search for it, and that happens to be, there happens to be one. So if I click on that, it will now show me that this is the footprint for that component. Now I want to change it, so I have to hit update. You'll notice here that it just changed to 0.1. I want to do the same thing to capacitor 3, so I will go to capacitor 3, and again I will hit update. You also get a little window on the bottom right corner. Now I've just changed the footprint on these components, so I'll close this out. If we click again on one of these components, now it still says 0.3. Hang on a second here. This one did change, but for some reason 3 did not change. So let's go ahead back and change it. I think I didn't click on it. That was probably the issue. So you have to click on it here, and then you have it highlighted here, and hit update. You should see it change. Once it changes there, you can close this window out. So now if I click on it, we have radial 0.1. Now we save our schematic before we can do anything else. And now if we go back to this one, you'll see that it's still the big capacitor, right? If we go back to printed circuit board view, we're still using the big capacitor. So we need to change that. We're going to go here, and we will do, on the top here is the little, we got a bunch that look like a sheet of papers, and it says update PCB with an arrow. We're going to click on that, and it will automatically update. It's going to tell us what it's doing. It's replacing capacitor 3 and 4, right? And we hit apply, and then it brings up this window, which we're not going to worry about for now, and we're going to close it. Now we have much smaller capacitors, right? Much more appropriate for what we're doing. So now what we can do is we can bring these are power smoothing capacitors, so we want them close to the power supply. And generally you want them also close to the IC. So I think we're fine here. You'll notice that capacitor 4 goes with capacitor 2 and capacitor 3 goes with capacitor 1, so we're going to rotate that. And then also I need to rotate that label there so we can see it. Let me just grab, sometimes it can be tricky to grab just exactly what you want. And we'll place these guys here so they line up kind of with the capacitors and with each other. I'm going to put these labels here. Alright. And looks like we're just going to go up a little bit. There we go. So now we've got a pretty straightforward routing here. Alright, now we can actually start making the connections. What we're going to be doing now is called routing our connections. So we need to tell the software where we want these connections to go. Now the software does have an auto routing feature. You have to download an extra component, but it's not super great, and it's good practice to just to learn how to do it on your own first at least. So we're going to go ahead and do that. Now remember, we talked about these layers. We have the top layer, the bottom layer. This is a 2-layer PCB, right? So it's going to have one layer of tracks on the top and one on the bottom. Now this is such a simple printed circuit board that we could probably do it all on one side, but I'm going to demonstrate using both of those layers. Now you can actually create a 4-layer PCB, but that's when they start getting super expensive. So for Eurorack generally, unless you start doing serious microprocessor type boards, you can generally get them done with just 2 layers. You'll notice our top layer is red and our bottom layer is this dark blue. We're going to choose our top layer to start out our routing. Okay. Let's go ahead and do the power area, the power lines first. I'm going to show you later on. I'm going to show you what a ground plane is and how we can put one in on this. But for now, we're just going to do all the connections direct, right? So anywhere that the line goes, the rat's nest line goes, we have to connect. So I clicked on the top layer on the pencil here, and then I also clicked on the wire. And I'm going to click in the center and connect there. Now the snapping is dictated by the same snapping that we did when we were moving the components around. So I'm going to connect all these guys up, right? Now we've got all of our grounds connected here, right? And then we need to connect. Now you have options here. You can click on the start and click on the finish and let the computer make the connection, right? Or you can route it the way you want. You can also click on the wire. I can go here, click once, here, click once, and then click again. So generally you want, of course, the straightest connections you can, but sometimes you need to go around things, and that's how you do it. You just click as you're creating that connection. So I'll click down here, and I'll click here and connect. I'll click here and I'll connect there, and automatically when the program finds the shortest connections, right? So right now it's basically saying that the way to connect this ground is the fastest is to go, or the shortest is to go around this way, right? So we can just do that. Now you can also make the choice. For example, let's say I wanted to connect this to this ground. I can just go here and connect it like that, even though there's no line between it, and then you'll see that that line disappears because now they're all connected to ground, right? Let's go ahead and connect our plus 12 volts, and we'll connect those guys. Those are the easy ones, right? They're all straight, no issues. Now we've got a few, you know, when we start talking about this IC, that's when the routing starts getting interesting, right? So let's figure out how we can do this, right? The power pins on the TL074 are here in the middle. We got 12 volts and we've got minus 12 volts, right? So let's go ahead and route those. The first one's pretty easy, right? We can just come over here. Now notice if I try to click in this pad, I can't do it, right? I can't connect 12 volts to ground. They don't go together. So the software prevents that from happening. I also cannot cross paths with another layer, right? So if I click here, for example, and then I try to come down, it stops me. Even though I'm moving the cursor, it stops because that doesn't make sense. It won't let me cross layers, right? So let me go ahead and delete this. I will click on the wire tool, and I'll go here, and I'll connect it. Simple, right? Now we need to connect this minus 12 volts. Now with these pins, you can go between the pins, right? This trace is small enough to go between pins, but we're going to go ahead and go around this way, right? So I'm going to click a few in, and then I like them when they got the little angle on them. You can just go straight if you like, right? Doesn't matter. So part of this is user preference. There we go. Now we're connected, right? So we got plus and minus. Let me show you something too here. Over here on the nets, it shows us the ones that are totally connected and the ones that are not, right? So if I refresh that, the 12 volts and the minus 12 volts are now connected because the only things connected to power is this one chip, and we've just connected it. So these two are good, but we haven't made all these other connections yet, right? Now, we know that there's feedback loops in these on the op amps that are at least one of them is directly connected, right? The one that goes on pin 1. So if you look, if I connect here, it needs to be connected directly. So I can just go straight across here, boom, it's connected, right? And then it is also connected to pin U1_1, right? So now if I try to go this way, what happens? Boom, I get stopped, right? So I'm going to go up this way. I'm going to come around here. Now it certainly is a printed circuit board design is an art, right? And you'll learn some rules and some best practices and things like that. But this is I'm just showing you kind of down and dirty a quick way of getting started, right? Now when you see that U1_1 needs to connect up here, right? So I could just draw straight across like that. That's one way of doing it. But if I want to, I can connect directly to a track. So I can just go like that. Boom, now it's connected, right? These 3 pins are all connected. Alright, let's see here. Let's do our R5. While we're here, let's talk about the labeling of components on a printed circuit board. We've got R5 is the label from the schematic, right? So we'll click on that, and if you look over here on the right, you have display prefix. It says yes. The prefix is R5. The name of the component is 100 ohms, right? That's what we called it. If sometimes you want the R prefix and sometimes you want the ohms, or sometimes you want them both. If I change display name to yes, now I have the 100, right? So I can put the 100 here on top of the component. Now that helps because when you're putting the component, you can see right away that you need a 100 ohm resistor there. So I like to do that. And you can do that on each of your items. So we'll say yes, we'll change the display and we'll add the 100 ohms on that one. Same thing with this chip, right? I want it to say TL074. So if I click on display name and yes, then I can grab this and drag it down here. Now, you don't have to worry. This is called the silk screen. This is the printing that goes on the printed circuit board, and you can print on top of traces. So you don't have to worry about that, right? You can put that right on top of that trace with no issues. Alright, let's make some more connections. We're still on the top layer, red. I'm going to click on the wire button, and we will connect that each end of that 100 ohm resistor, right? We're also going to connect this R4 here. It's going to go up here, and you'll notice that this pin here goes to there. So now we got that connected. Alright, we got most of the easy ones, quick easy ones done. Let's do some from up here, right? If we go to jack 1, we need to connect from here to here, no problem. And then we're going to connect from, this is connected to ground. Actually, let's move this R2. Let's move it up here. Right. Now you'll notice I just went over J2. I can grab that and move that out of the way. Right. So these guys are connected. You'll see that as I drag it, the rat's nest goes along with it. Now I know I want this R2 to be down here, right, with this one. So let's move it there so it's easier to tell which is which, right? This one I'm going to add the display name, 1K, put that down here. Same thing with this one, we'll add the display name, 4.7 megs, and move it down here. Alright, let's make some connections up here. This is the ground pin on these jacks, and so we'll connect it to that. Now this one I can either connect from here to here, so let's just go, oops. If you get something weird like that, just hit Control-Z, hit escape, to get out of it. You might have to delete something if you messed it up like I did. When you click, you want to make sure you have that highlighted. Connect that there. Connect that there. Connect this there. Alright, making progress. Now this goes to ground, which is all the way down here, and you'll notice that I don't have a super easy way to get there. Let me show you one way to get there. I could go all the way down here. I can come around there and go like that. Now it's connected to ground, right? If I refresh this, now ground has now been taken care of, along with some of the resistor connections. Alright. These two are both connected, so I'll choose the wire and I'll connect these two. Now this, I'm going to replace some of these ones. I'm going to move this guy up here because it's connected to that one. And I'm actually going to rotate it twice here. Okay, you'll notice that it does rotate the label, so you want to rotate that back so it makes it look good. We'll go ahead and click on that, and we'll add the display name and do 100. Now for the jacks too, we can change the display name, right? So let's click on a jack and we'll say yes, and that tells us input, and you can stick that wherever you like. This is jack 2, so this is out 1. This is helpful when you're putting your components on because it helps with making sure you have things in the right spot. You don't actually put output 2 on top of the input or something like that. So let's go ahead and move this here. And finally for this jack we'll say yes, and we'll move that over here. Now keep in mind when you place the components, if you put this inside here, it's going to get covered up. If you leave it outside, it won't get covered up. So that's again user preference, right? Alright, let's do some more tracks. We're still on the top layer, the red layer, and let's go ahead and we'll route this one this way. Hopefully you can see what I'm doing okay. Same thing with the schematics. If you want the track to go a certain way, you have to click where you want it. Right, and I'll zoom in here and I'll just connect it like that. Simple enough. Alright, now this is where it starts getting a little complicated, right? Because we have traces that cross each other. We got this one that comes all the way down here. So let's go ahead and connect this guy here. Like that, and we'll connect this guy to here. So let's see, we've only got 2 left, right? That's pretty simple. Now let's see, is there any way we can do this with only using this layer? Yes, I see a route. So if I click here and I click here, I can go this way, and I will not cross any other red tracks, right? Now this one, let's see if we can do this. We're starting from here and we've got to go all the way down to here. So we can see right away that we have an issue, right? Because can't go this way, I would cross this one. Can't go this way, I would cross this one. So we're a little bit challenged, right? Can't go down. Now I could try to go between these somehow, but that would get a little bit tight, right? Like I said also, oh, we have another one we have to do here. So let's go ahead and do this one here. Make it look nice a little bit. And if we refresh, let's see where we're at. Yep, we only got one left. Right, we got this one going all the way up to here. So for this one, let me show you how to do a second layer. Right, so we click on the bottom layer. So now we're working on the bottom of the PCB. As long as we don't cross any pads that go through the PCB, we can put this anywhere we like. So for example, I can click here. I can run right over these red lines, right? Because again, I'm on the bottom of the board. I'm not on the top layer anymore. I can also go through in between these pads, right? Now I still can't go through a pad like this because that hole goes all the way through and it's plated on both sides. So I cannot do that, but I can just do that, right? Alright guys, we've completed our printed circuit board. If I do a refresh, now everything is good, right? It says we're good. So, pretty cool. That's the end of this section of this tutorial. There's still more things. I did not cover the ground plane, and I also didn't cover how to do vias so that you can take a signal from the top of the board and route it down to the bottom of the board. But I'll cover that in a future quick video and show you guys how to do that. But thanks for looking. I hope you find this recording a little bit helpful. The next video will be creating an actual panel for this.